All right, so hope everything's all right. Hope you're doing well. So looking at the problems that you gave, looking at y equal to 1/2 x squared, square root of 49 minus x squared. So we're looking at doing the product rule here, wherein I would call 1/2 x squared u. Didn't have to include the constant with u, but might as well. Take the derivative of that. Bring down your 2, subtract 1 from your exponent. 2's cancel. Leaves you with just x. All right. And then v square root of 49 minus x squared. And then v prime, derivative of v. So I want to rewrite this. 49 minus x squared raised to the 1/2. So to take the derivative of that, bring down the 1/2. 49 minus x squared. Subtract 1 from this exponent. It's going to be negative 1/2. 1/2 minus 1 will give you a negative 1/2. Then you take the derivative of what's under the radical. And that'll just be negative 2x. So if I want to simplify this, these 2's would cancel. And I would bring this together, this negative exponent. So that'd be negative x over 49 minus x squared to the 1/2 power, or negative x over square root of negative, or square root of 49 minus x squared. All right. Quick. Okay, so when we look at the product rule, if you have the derivative of uv, that's going to be u plus v prime, e plus u prime. All right. So u is 1/2 x squared times v prime, which is negative x, square root of 49 minus x squared, plus v, which is the square root of 49 minus x squared, times u, which is x. And okay. So let's simplify this. The 2 and the square root of 49 minus x squared is in the denominator. X squared and negative x is in the numerator. So it's negative x cubed. 2 square root of 49 minus x squared plus x times the square root of 49 minus x squared. And let's see, the things we can do with this. We could bring it together, but it's probably not necessary. This should be good enough right here as your final answer. So let's look at the next one. Of course, if you try into this, if you have any questions on it, let me know. We have y equal to cosine of pi x to the 7th power. So taking derivative of this, So just like before, when we were looking at the square root of 49 minus x squared, you take the derivative of the outside piece and the derivative of the inside. So the derivative of cosine is negative sine. So you keep everything else the same. Then you take the derivative of this inside, bring down 7. As a matter of fact, let's do this. Just want to make sure I do this properly. Now 7 needs to go to both pieces. So let's put pi to the 7th, x to the 7th. So now when I do that derivative, because pi to the 7th is a constant. So you don't want to confuse that. So it's pi to the 7th times 7 x to the 6th. All right, so now we can simplify this, bring all the stuff to the front, and it should be negative 7 pi to the 7th x to the 6th times sine of pi x to the 7th. So that should be an answer there. All right. 2 more here, looking at implicit differentiation. The next two, we have the square root of xy equal to x to the 6y plus 30. So we're going to apply the derivative with respect to x to each piece. Here, I would rewrite this, the exponent of x to the 1/2, excuse me, exponent of 1/2. And then also, this is x to the 1/2, y to the 1/2. All right, and like I said, you're going to apply derivative with respect to x to each piece. Yeah. So in both of these cases, we have to do the product rule. And of course, derivative of any constant is 0. So derivative of 30 with respect to x is 0. All right, so looking at this piece, I'll say this is u prime is going to be 1/2 x to the negative 1/2. And then if v is y to the 1/2, and derivative of y to the 1/2 will be 1/2 y to the negative 1/2 dy dx. Let's see if I can get this over here. So x to the 6, q prime, 6x to the 5th. And then v is y, v prime, which is dy dx. All right, u times v prime plus v times v prime All right, 1/2 of one. Let's see. Then I bring it down. Okay. All right, just making sure. So this is going to be x to the 1/2. Negative exponent right here for your y. So bring that down. And then 2. That's dy dx plus y to the 1/2 to x to the 1/2. All right, so this is that one piece over here. Let's take this over here. So u is x to the 6, u prime dy dx plus y times v prime. So we have u times v prime, v times u prime. Simplify this. And that's this piece. Let's put it all together and look to solve for dy dx. This is what we have now. So we need to get both of our terms dy dx to one side of our equation. Doesn't matter which side. And then the other term without dy dx to the other side. So take this over here, take this over here. Cancel. Cancel. All right, so this is what we have. I'll make sure nothing else can be done in order to simplify this before I go finish it off. I guess I could make more work. So let's just go ahead and if I take this 2y to the half multiplied by p. Yeah, I guess I could make it a little more simple. Okay, if I wanted to get rid of this stuff in my denominator, I can multiply both of them by the LCD of 2x to the 1/2, y to the 1/2, just so I can get them out of these denominators. So make this stuff less complicated or less involved. So I will multiply like I said, each term by that. Let me see. I'm gonna write that up here. So I'm gonna multiply that to each term. So what that does is 2 will cancel out here. Y to the 1/2 will cancel out right there. And then 2 cancel out here. X to the 1/2 cancel out right here. All right. So what happened here is I have x to the 1/2 times x to the 1/2, 1/2 and 1/2. When you talk about adding your exponents, that's going to be just x. Now here we have 1/2 plus 6. 6 1/2. That's not going to be, that's clean. 13 over 2 over 2 dy dx. And then here we have 2 times that's 12. It's going to be 11 over 2. And that'll be 3 over 2. And then we're just left with this 1/2. So that's be minus y. All right. And we can make this a little more simple in a second. But right now, let's go ahead and factor out dy dx. That leaves me with x minus 2. 13 halves. 9 halves. It wasn't yet. All right. And so now I can divide both sides of this quantity. So it should be different variations of this answer that WeberSign will accept. So that should be your answer right there. And I could rewrite this way. Just cleans it up a little, but just taking this half that we had down here for both of them, make the square root. Same thing right here, making the square root. But either one of these answers should be good enough. All right, then we have one more that you gave. Let me see one thing. Go back to. All right, so we want to derive this implicitly once again. So taking derivative of both sides with respect to x, derivative of 0 of 8 is going to be 0. And then over here, we need to take the derivative of the inside and derivative this outside. So the first thing we do is look at the outside. So it's going to be 7 sine pi x. Let's cosine pi x, pi y, excuse me, raised to the 6th power. Then it's going to be times the derivative of the inside. So the derivative of sine is going to be cosine pi x, then derivative of what sign is being applied to, which is pi x. So it's pi, then plus derivative of cosine. It wouldn't be plus, it would be minus, it would be negative sine pi y. Then derivative of pi y is going to be pi dy dx. And all that's equal to 0. Run out of space. I'll put that down here. All right. So now we need to solve for dy dx. Now this whole quantity is redistributed to each piece here. So let me rewrite it like this first. So pi cosine pi x minus pi sine pi y times dy dx equals 0. So I'm going to take this and multiply to each piece. So it'll be 7 pi cosine pi x times sine pi x plus cosine pi y to the 6 minus, I'm going to put this down here, 7 pi sine pi y and sine of pi x minus cosine pi y raised to 6 dy dx equals 0. All right. So now since this is minus, I'm going to go ahead and add this quantity to both sides. All right, so there's a lot to write, so I'm just going to write it. It already been done. With it already being done. Hold on, I could have divided this out and gotten rid of this in the beginning. Anyway, you'll see what I mean in a second. All right, so x minus cosine to 6 equal to 7 pi sine pi y and pi x minus cosine pi y to the 6 dy dx. All right, so now I need to divide both sides by this quantity so that I can have dy dx by itself. So I have 7 pi cosine pi x y raised to the 6 over 7 pi sine pi y sine pi x minus cosine pi y to the 6 equal to dy dx. So if I was paying attention, you see how sine pi minus cosine pi y to the 6 cancel out, and that 7 cancels, and our pi cancels. And I could have did that instead of distributing here. I could have just divided both sides by that here, and it's 0 because we had 0 here, would have canceled it out. So I added a little bit of extra work. But my fault. Either way, as long as you get to the right answer. Sometimes, you know, what happens in the process of teaching and learning. But yeah, that's it right there. Just making sure I didn't miss anything, leave anything out. You want back here, I will. Yep, and divide it. Pause or cancel units on power. Yep, this is our answer. All right, let me know if you have any questions.